Relations and Functions. This is the name of the first chapter of Mathematics of Class 12th. And here in this video, I am going to explain the term relations. Now let's try to understand the term relations. In mathematics, we come across many relations such as line L is parallel to line M, set A is a subset of set B, set P is the superset of set Q, triangle ABC is congruent to triangle PQR, 5 is less than 10, 21 is greater than 11, under root 25 equals to 5. Symbols such as less than, greater than, equals to, does not equal to, belongs to, subset, proper subset, superset, etc. are called relations because they convey relationships among some quantities or things. In all these examples, we notice that a relation involves pairs of objects in certain order. Two objects or quantities are related if there is a recognizable connection or link between the two objects or quantities. Before understanding relations, we have to understand the Cartesian product of two non-empty sets. Because without having the knowledge of Cartesian product of two non-empty sets, we are unable to understand the term relations. So first we try to understand the Cartesian product of two non-empty sets. Let A is a set of two colors and B is a set of three objects. Let the elements of set A are red and blue and the elements of set B are B, C, S, where B denotes bag, C denotes coat, S denotes shirt. And this is a ray diagram, and with the help of this ray diagram, we represent the elements of set A and set B. I mean, with the help of this ray diagram, we represent the elements of first set and the elements of second set. At the bottom side of this ray diagram, we represent the elements of first set, I mean the elements of set A. And at the left hand side, which is vertical, we represent the elements of set B. So at the bottom side, which is in the left hand side, we represent the first element of first set, I mean the first element of set A, and then we represent the second element of first set, I mean the second element of set A. And here left hand side, which is vertical, we represent the elements of second set, I mean the elements of set B, but we start from the lower side. So you have seen that at this point, which is the bottom side and left hand side, we represent the first element of set A, and other side at bottom we represent the second element of first set, I mean the second element of set A. From this point, you can see properly, from this point we start to write the elements of set B. Here we write the first element of set B, then we write second element of set B, then we write third element of set B. So you can say that B is the first element of set B, C is the second element of set B, and S is the third element of set B. Suppose you have two sets and the number of elements in set A are 3 and the number of elements in set B are 6. Then with the help of this ray diagram, you will represent the elements of set A and set B like this. At the bottom side, from the left hand side, you will start writing elements of set A. At left hand side, which is bottom, you will write the first element of first set, then second element of first set, then third element of first set. And from this point, which is at left hand side but which is vertical, you will write from the lower side and you will start writing the elements of second set. I mean the elements of set B. From this point, you will start writing first element of second set, then second element of second set, then third element of second set, then fourth element of second set, then fifth element of second set, then sixth element of second set. So this is the way of representing elements of two sets to perform the operation of Cartesian product. Here in this example, we have two sets, set A and set B, and the elements of set A are red, blue, and the elements of set B are B, C, S, where B denotes bag, C denotes coat, S denotes shirt. Now, with the help of the elements of set A and set B, we get the pairs which are in a very orderly manner. And the pairs are red bag, red coat, red shirt. Then blue bag, blue coat, blue shirt. When we write pair in an orderly manner, then first we write X and then we write Y, where X is an element of first set and Y is an element of second set. But these elements of first set and second set are in a very orderly manner. Now try to understand the method of getting pair perfectly. First element of first set and first element of second set, and we get first pair. First element of first set and second element of second set, and we get another pair. Then first element of first set and then third element of second set, then we get another pair. Similarly, when all the elements will be used of set B or second set, then we get another element from first set. Here we take second element of first set, and then with that second element of first set we take first element of second set, and again second element of first set, and with this element we take second element of second set, and again with the second element of first set we take the third element of second set. In this way, this is the general way of getting the pair in a very orderly manner in the Cartesian product of two sets. So in this way we get the pairs in a very orderly manner while performing the operation of Cartesian product of two sets, set A. Now we can define the Cartesian product of two non-empty sets. If we are given two non-empty sets P and Q, then Cartesian product of P and Q is the set of all ordered pairs of elements from P and Q. And in set builder form, we write the Cartesian product of two sets like this. Suppose we here represent the Cartesian product of P and Q, then the Cartesian product of P and Q is equal to the set of all ordered pair P and Q such that P belongs to set P and Q belongs to set Q. Hence, now we are able to write the Cartesian product of the two sets A and B. So this is the Cartesian product of two sets A and B, and its ordered pair objects are red bag, red coat, red shirt, blue bag, blue coat, blue shirt. This is the Cartesian product of two sets A and B, where red and blue are the first elements of the ordered pair which belong to set A, and bag, coat, shirt are the second elements in the ordered pairs and they belong to set B. In each ordered pairs, first element of each pair belongs to first set, I mean set A, and each second element belongs to set B, I mean second set, set 2. Here some points are to be noted. So first point is the order in which the elements of the two non-empty sets are paired is crucial. The order in which the elements of the two non-empty sets are paired is crucial. Implies that you can't write Cartesian product of set P and set Q is equal to set Q and set P. Hence we write the Cartesian product of set P and set Q is not equal to the Cartesian product of set Q and set P. So in simple way we say that the product of P and Q is not equal to the product of Q and P. Or if you have two other sets A and B, then you can write the Cartesian product of A and B not equal to the Cartesian product of B and A. Now second point is to be noted, if either P or Q is the null set, if we are finding the Cartesian product of two sets P and Q, and if either P or Q is the null set, then the Cartesian product of P and Q will also be null set or empty set, because null set or empty set is same thing. Implies that Cartesian product of P and Q is equal to phi, because phi denotes empty set. Remember, two ordered pairs are equal. Two ordered pairs are equal if and only if the corresponding first elements are equal and the second elements are also equal. Otherwise, the two ordered pairs are not equal. Second point, if there are P elements in set A and Q elements in set B, then there will be PQ elements in the Cartesian product of set A and B. Implies that if the number of elements in set A is equal to P and the number of elements in set B is equal to Q, then the number of elements in the Cartesian product of set A and B is equal to PQ. Suppose you have 3 elements in set A and you have 2 elements in set B. Then if you find the Cartesian product of set A and B, then you will get total number of pairs is equal to 3 multiplied 2 is equal to 6. So the number of pairs in the Cartesian product of A and B will be 2 multiplied 3 is equal to 6. Now third point is, if set A and set B are non-empty sets and either A or B is an infinite set, then so is A into B also. It means if you are finding the Cartesian product of two sets where these two sets are non-empty sets, but one of these two sets are infinite, then the number of ordered pairs in the Cartesian product of A and B will be infinite. Now the fourth point is that the Cartesian product of 3 same sets will be written like this. If suppose the given set is A, then Cartesian product of A and A will be written in set builder form like this. The set of all A, B, C, which is the ordered triplet. So we can say that the set of all ordered triplet A, B, C such that A, B, C belong to set A. This is the representation of Cartesian product of 3 same sets in set builder form. To understand relations perfectly, let us consider the two sets P and Q. Let the elements of set P are A, B and C, and the elements of set Q are Ali, Bhanu, Binoy, Chandra and Divya. There are 3 elements in set P and 5 elements in set Q, as number of elements in set P is equal to 3 and number of elements in set Q is equal to 5. Therefore, the number of elements in the Cartesian product of the sets P and Q is equal to 3 multiply 5 is equal to 15. This 15 indicates that there will be 15 ordered pairs in the set of the Cartesian product of P and Q. Hence, these 15 elements will be A Ali, A Bhanu, A Binoy, A Chandra, A Divya, B Ali, B Bhanu, B Binoy, B Chandra, B Divya, C Ali, C Bhanu, C Binoy, C Chandra and C Divya. These are 15 ordered pairs in the Cartesian product of P and Q. We can now obtain a subset of the Cartesian product of P and Q by introducing a relation R between the first element X and the second element Y of each ordered pair X and Y. Let us consider the relation R is equal to the set of all ordered pair X and Y such that X is the first letter of the name Y, where X belongs to the set P and Y belongs to the set Q. Here this is the first set P and this is the second set Q, and these are the elements of set P and these are the elements of set Q. And this represents the relation, and relation says that X is the first letter of the name Y. So we can see with the help of this visual representation of the relation R that A is the first letter of the name Ali, B is the first letter of the name Bhanu, B is the first letter of the name Binoy, C is the first letter of the name Chandra. Hence, this arrow diagram represents the relation. Hence, the relation R is equal to A Ali, B Bhanu, B Binoy and C Chandra. Here you can also see that A Ali, B Bhanu, B Binoy, C Chandra. This represents the ordered pair in the set of relation. Here we notice that relation is a subset of the Cartesian product of P and Q. This symbol of subset indicates that in relation R, all ordered pairs of the Cartesian product of P and Q may or may not be included. What is the definition of a relation? A relation R from a non-empty set A to a non-empty set B is a subset of the Cartesian product A and B. I mean A multiply B. The subset is derived by describing a relationship between the first element and the second element of the ordered pairs in A multiply B. I mean the Cartesian product of A and B. The second element is called the image of the first element. Remember this thing, that second element is called the image of the first element. For example, in the relation R, which we have just studied, Ali is the image of the letter A, Bhanu is the image of the letter B, Binoy is the image of the letter B, Chandra is the image of the letter C. Relation in a set. Now try to understand relation in a set. A relation R in a set A is a subset of A multiply A. Thus, R is a relation in a set A if and only if R is a subset of A multiply A. If ordered pair A and B belongs to the relation R, then we say that A is related to B and we write A capital R B. But we read it A is related to B. If ordered pair A and B does not belong to the relation R, then we say that A is not related to B. And we write A crossed R B. And we read it, A is not related to B. For example, let the elements of set A are 1, 2, 3, 4, 5, 6. And let R be a relation in set A, given by R is equal to the set of all ordered pair A and B such that A minus B is equal to 2. Then all the ordered pairs in the set R, which gives the relation, are 3, 1, 4, 2, 5, 3 and 6, 4. Because 3 minus 1 is equal to 2, 4 minus 2 is equal to 2, 5 minus 3 is equal to 2, 6 minus 4 is equal to 2. Thus we can say that 3 is related to 1, 4 is related to 2, 5 is related to 3, 6 is related to 4. But we can say one thing more. 1 is not related to 3 because 1 minus 3 is not equal to positive 2. Similarly, 2 is not related to 4 because 2 minus 4 is not equal to positive 2. Similarly, 3 is not related to 5, 5 is not related to 6, etc. These pairs are not related to each other. Remember one thing, a relation may be represented algebraically either by the roster method or by the set builder method. Total number of relations. How many relations we can get from the Cartesian product A multiply A or A multiply B? The total number of relations from set A to set B is the number of possible subsets of A multiply B. The total number of relations from a set A to set B is the number of all possible subsets which we get from the Cartesian product of A and B. If number of elements in set A is equal to P and number of elements in set B is equal to Q, then the number of elements in Cartesian product of A and B, I mean A multiply B, is equal to P multiply Q. But the total number of relations is equal to 2 raised to the power P multiply Q. I mean 2 raised to the power PQ. Now try to understand some important things. First, range of relation R, second, domain of the relation R, and third, codomain of the relation. So what is the range of the relation? The set of all second elements in a relation R from a set A to a set B is called the range of the relation. For example, Ali, Bhanu, Binoy, Chandra. These are the range of the relation R. Domain of the relation R, the set of all first elements, the set of all first elements of the ordered pairs in a relation R from a set A to a set B is called the domain of the relation R. For example, A, B, C are the domains of the relation R. Now try to understand codomain. The whole set B or the whole second set, the whole set B is called the codomain of the relation R. For example, codomain of the relation R, Ali, Bhanu, Binoy, Chandra, Divya, because these are the elements of the whole second set. Remember, range is a subset of codomain. Range is a subset of codomain. Now again, try to understand domain, range and codomain with another example. Domain of the relation R will be represented in set builder form like this. the set of all first element A such that every ordered pair A and B belongs to the relation R. Range of relation is represented in set builder form like this. The set of all second element B such that every ordered pair A and B belongs to the relation R. And codomain of R is equal to whole second set. For example, let the elements of set A are 1, 2, 3, 4 and up to 16. I mean all the elements from 1 to 16 are included in the set A. And let R be a relation in set A given by R is equal to the set of every ordered pair A and B such that B is equal to A square. B is equal to A square. It means second element in the ordered pair is the square of the first element in the ordered pair. That's why we get the relation, we get all the ordered pairs in the relation 1, 1, 2, 4, 3, 9, 4, 16. Because the square of 1 is equal to 1, the square of 2 is equal to 4, the square of 3 is equal to 9, the square of 4 is equal to 16. Now domain of the relation R, you know that domain is the first element in the ordered pair in the relation. That's why in relation all the ordered pairs which we have, first elements are 1, 2, 3 and 4. Hence domains of the relation are 1, 2, 3, 4. 1, 2, 3, 4, these are the elements in the set of domain for the relation R. Range of relation R, we know that range is the second element in the ordered pairs of the relation R. And we see that 1, 4, 9 and 16, these are the second elements in the relation R in ordered pairs. Hence, all the elements of the range of relation is equal to 1, 4, 9, 16. And codomain is the whole set A. So in this video, we have learned Cartesian product, relation and domain, range and codomain. I hope this video is beneficial for you. If you have not subscribed the channel, then subscribe the channel to get the notifications of the next video. And in my next video, I will explain all the types of relations in a very detailed way with some examples so that you can understand all the types of relations perfectly. So thanks a lot for watching this video.